Hey everybody, and welcome to this next video on calculating the area and perimeter of different shapes. Shapes including rectangles, trapezoids, parallelograms, and yeah, and yeah, not recording, and yeah. All right, you gonna keep this thing going. I'm not gonna stop it. Okay. First example is how to calculate the area of a rectangle. So let's draw a rectangle and calculate the area of it. Area of a rectangle. Use the letter A for area. Is going to equal, and is going to equal length times width. Here's my rectangle. Again, here's my rectangle. I have a length of 32 meters. So L, or the length, equals 32 meters. And my width equals 20 meters. So I let L represent the length, W represent the width. So my area is going to be 32 meters times the width, which is 20 meters. The area is going to be 32 times 20, which gives me 640. And then meters times meters gives me meters squared. And that's our first example. Suppose for the next problem, example 2. For example 2, suppose we're given the area and the length, and we're asked to find the width. So if the area is 168 square feet, squared, and the length is 14 feet. What is the width? Well, let's write our formula, plug in the values that we know, and solve for what we don't know. Area equals length times W. Area is 168 square feet, or feet squared. That equals my length, which is 14 feet, times W. To solve for W, we're going to divide both sides of the equal sign by 14 feet. And we're dividing because we're doing the opposite of multiplication. Running out of board space here, but W, well, the 14 feet cancel each other out. So W is going to equal, right over here, 168 feet squared divided by 14 feet is going to give me 12 feet. Again, here, I substituted in the area, the length, looking for the width, had to divide both sides of the equal sign by 14 feet. So 14 feet divided by 14 feet leaves me W. For the right side of the equal sign, for the left side, 168 feet squared divided by 14 feet equals 12 feet. So W equals 12 feet. Now we're moving on to parallelograms. What's next is parallelograms. Good grief, Charlie Brown. Let's first draw a parallelogram and describe what we see, and then learn how to calculate its area. The most straightforward way to describe a parallelogram is it has four sides, 1, 2, 3, 4. This side and this side is parallel to each other. If I were to extend these sides, they would never intersect. If I were to extend this side and this side, they would never intersect. So I have two sets of equal length sides, but I do not have four right angles. That's the probably quick and dirtiest definition of a parallelogram I can give you. Now, I have a side of length L, this side here, let's call that length, just put the L in parentheses. And I have this height, I can call that H. And in some problems, you may see another height. And actually, when I do that, you can see I have a right triangle. Here I have a rectangle. And here I have another right triangle. Just good to see that within this one figure, you have two right triangles and one rectangle. Keep that in mind for later. For right now, to calculate the area, you multiply the length times the height. Or L times H. So now for this example, we're going to draw another parallelogram, add some numbers, and calculate the area. So now we have this parallelogram. So now we have this parallelogram that has this side equals to 8, this side is 5, here to here is 5, here to here is 3, and here to here is 5. And we have the height, which is equal to 4. Well, before we can use our formula, area equals to the length. Oh, I'm sorry, I gave the answer. That's okay. Pretend we don't know what H equals. Area equals length times height. But here for this right triangle, we don't know what the height is. But we know we do have a right triangle that has a hypotenuse or hypotenuse of 5. and it has a hypotenuse of 5 and one side equal to 3, and we'll call that side A. So then to find H, we're going to use our Pythagorean theorem. C squared equals to A squared plus H squared, where C squared is our hypotenuse, A squared, where A is the base of the triangle, and H is our height. We're going to substitute the values for C and A into our formula, then solve for H. C was equal to 5, so we have 5 squared equals, A is equal to 3, so we have 3 squared plus H squared. That gives us 5 squared, which equals 25. And that equals 3 squared, which equals 9. Plus H squared. Now we subtract 9 from both sides. And that gives us on the left side of the equal sign 16. And that equals H squared. Now to get H by itself, we take the square root of both sides. That leaves us with square root of 16, which equals 4, equals the square root and the exponent 2 cancel out, leaving us just H. So H equals to 4. Our height of that right triangle equals to 4. So now, to find the area, we can multiply the length, which is 8, times the height, which is 4. And 8 times 4 is 32. Next figure is a trapezoid. So a trapezoid has 2 bases A short base from here to here, we call that B2. And a long base from here to here, we call that B1. Or this could be B1, that could be B2. The point is that it has two bases, a small one and a long one, and it has a height h. And here's the formula to find the area. What we do is we add base 1 plus base 2, get an answer, divide that by 2, and then multiply that times the height. In our next example, we're going to draw another trapezoid, put in some numbers, and calculate the area. So for this trapezoid, we have a base here that's equal to 6. We have a height that's equal to 6. For this right triangle, it has a hypotenuse of the square root of 85. And for this right triangle, what we're given is it has hypotenuse of the square root of 52. Well, first things first, we need to find the base for this triangle with the hypotenuse of square root of 85. So we're going to call that base just B. B. So we're going to use our Pythagorean theorem here to solve for B. Our hypotenuse squared, so it's the square root of 85 squared, equals 6 squared plus B squared. Because remember, for your Pythagorean theorem, it's your hypotenuse squared is equal to one of your legs or sides squared plus the other side squared. So now the square root of 85 squared, you can use your calculator, or I can just tell you that when you square a square root, you get just what's underneath the square root sign, which is 85. So the square root of 85 squared is just 85. Six squared is 36. And then plus b squared. Now to solve this for b, well, first we have to subtract 36 from both sides. When I do that, that's going to leave me on the right side of the equal sign. B squared is going to equal 85 minus 36, which is 49. So now to solve for b, I take the square root of both sides. So the square root of 49 is 7. Actually, there are two values when you take the square root. There's a positive and a negative. But we want the positive because we're talking about a figure here and the length of a side, and a length of a side cannot be negative. So we want the positive 7. And that equals, well, the square root of b squared is just b. So then that b up here, the base for this right triangle, b equals 7. Now in the middle, we have this rectangle that says from here to here is equal to 6. Then here to here has a length of 6. Because with a rectangle, opposite sides have the same length. Now, since this side had a length of 6, this side has a length of 6. And this height is equal to 6. This height is equal to 6. One thing I left out is from here to here, this entire length is 17. If I can somehow squeeze that in, let's see. Okay, hopefully this isn't too bad on the eyes. The length from here to here is 17. The distance from here to here is 6. And the distance, and the base of this right triangle is 7. We just calculated that here. We need to calculate this base for this triangle who has a hypotenuse of square root of 52 and a height of 6. We're going to use the Pythagorean theorem to calculate the base of this triangle. So the hypotenuse squared, which is the square root of 52 squared, is going to equal 6 squared plus a squared. Where the a represents the base of this right triangle. So the square root of 52 squared equals 52, equals 6 squared is 36, plus a squared. We're going to subtract 36 from both sides. (16) equals to a squared, and take the square root of both sides to find out what a equals. A is going to equal square root of 16 is 4. Remember, it has a positive or a negative. It would be plus or minus 4. That's the actual definition for the square root of 16. But we want the positive value. So positive 4. Whew. So now, you know, I spoke prematurely again. Maybe too many videos in one day. I did not know that this entire base was 17 at first. Because I did not know what the value of this base was. I did not know the distance from here to here was 4. Right? I didn't know what that was. That's why we used the Pythagorean theorem to find the base of that right triangle. Once we calculated the value for that base and found out that it equaled 4, then when I add 4 plus 6 plus 7, that gives me 17. And that's how I know that the length of the long base is 17. We're going to call that long base. So I have the long base, that's 17, and the short base, which is 6. Let's erase some of the calculations to make it easy to look at. So my long base is 17. My short base is 6. Short base meaning the distance from here to here. So now the area of a trapezoid is given by this formula. The area of the trapezoid. The area of the trapezoid equals the long base plus the short base divided by 2 plus h. I think in the previous part of the video or previous section, the long base was what, B2, B2, and the other one was called B1. Anyway, I think you understand. So let's plug in our values and find out what the area equals. Area equals, okay, long base is 17 plus the short base, which is 6, divided by 2 times the height of 6. Area equals 23. 17 plus 6 gives me 23 over 2 times 6. And when you do all of the calculations, well, we can change that 6 to a fraction by putting 1 as its denominator. 2 and 6 have a common factor of 2. So 2 divided by 2 is 1. 6 divided by 2 is 3. So now I have my area equals 23 times 3, which is 69 over 1. And 69 divided by 1 is 69. So the area for this trapezoid is 69. But notice that we had to use the Pythagorean theorem twice to find the bases for the two triangles. Once we had those bases, then we could use that information to calculate the area for the trapezoid. Next figure is a triangle. So you have a triangle that has a base and it has a height h. And the formula for the area is 1/2 base times height. Or 1/2 times b for base, h for height. So if I'm given the area and the base, let's calculate the height. I know my area in this example is 45.5 inches squared. And my base is 7 inches. And what does the height equal? So area, 45.5 inches squared, base the 7 inches, height equals what? Well, let's substitute our values in for the variables and then calculate and find out what h equals. So put in 45.5 inches squared equals, that's what my area is, A equals this. So A equals 1/2 times 7 inches times H. So now this gives me 45.5 inches squared equals 1/2 times 7 over 1. 1 times 7 gives me 7 for my numerator. 2 times 1 gives me 2 for my denominator. Inches times my height. To solve for h, I can multiply both sides by the reciprocal of this fraction, 7/2, which is 2 over 7. And I multiply by the reciprocal because I need to get h by itself. So I know that 7 over 2 times 2 over 7 gives me just 1. And 1 times h gives me h. On my left-hand side, I have 2 over 7 inches times 45.5. And when I do that math, I end up with 13 inches. So that's what my height equals, 13 inches. How'd I get 13? I multiplied 2 times 45.5. You get that answer. And then divide by 7, you get 13. Next, we're going to talk about parameter or parameter. All right. I want to find the perimeter of this rectangle, given I have this length of 21 meters and the width of 11 meters. Well, since this is a rectangle, I know that opposite sides are equal. So this side is equal to 21 meters. This side is equal to 21. And if this side is equal to 11, this side is equal to 11. So to find the perimeter, I just add up 11 plus 21 plus 11 plus 21. So P for perimeter equals adding up all four sides. 11 plus 21 plus 11 plus 21 meters. And that added all together gives me 64. So the perimeter of this rectangle is 64 meters. And you know, it doesn't matter if the figure is a rectangle or triangle. With perimeter, you still want to add all the values of the sides. We'll see that with the next example where we have a triangle. So we're going to have 3 sides, 3 values. We add up all 3 values to get the perimeter. So here's my triangle. And to find the perimeter, I'm going to add 18 meters plus 24 meters plus 30 meters. So P for perimeter equals 18 plus 30 meters plus 24 meters. And that's going to equal 72 meters. And that is the perimeter for that triangle. Next example for perimeter, suppose you have something that looks like this. So I have this shape that has the following sides. This side is 3 feet. From here to here is 3 feet. Here to here is 11 feet. I need to figure out what this is. From here to here is 14 feet. Here to here is 9 feet. Once I know what this equals, then I can add all my sides together to get the perimeter. Well, since I know from here to here is 14 feet, well, before I jump too far, let's start with this rectangle first, and I'm going to add a dotted line for. So for this rectangle, since this side is 11 feet, this side from here to here has to be 11, has to be 11 feet right here. And since this side of the rectangle is 3 feet, this side has to be 3 feet. Now for the bigger rectangle, meaning here to here to here to here, this side is 9 feet. So here to here must be 9 feet. Well, if this whole distance from here to here is 9 feet, from here to here is 3 feet, then this distance is just 9 minus 3, which is 6. And that was the missing side value that we needed for the shape here to here to here to here to here. So now I can erase all the other extra information that I used to help me find the length of this side that was 6 feet. So now I can just add all these values to get the perimeter. So the perimeter equals 9 feet plus 3 feet plus 3 feet. So 9 plus 3 plus 3 plus 11 plus 6 plus 14. Again, my perimeter equals 9 feet plus 3 feet plus 3 feet plus 11 feet plus 6 feet plus 14 feet. And all that added together equals to 46. Feet. And our last example of area, well, no, two more. Sorry. We're going to have a rectangle and a triangle in one figure, have to calculate the areas of both, and then add them together. So what I have is this rectangle here to here to here to here has a length of 5, a width of 6, and then I have this triangle that's on top of here. Now, because this is a rectangle, if this distance is 5 from here to here, then from here to here is going to be 5, which is actually is the base of the triangle. So from here to here, the value is 5. From here to here, the value is 5. So to find the area of the rectangle is length times width. My length is 5, my width is 6. And 5 times 6 is 30. So the area of my rectangle is 30. Area of my triangle is 1/2 the base times the height. I know my base is equal to 5. My height is equal to 8. So we're going to substitute those values in. Base, or B, equals 5. And my height, H, is equal to 8. Written as a fraction, put 5 over 1 and 8 over 1. So 1 times 5 is 5. 5 times 8 is 40 for my numerator. For my denominator, 2 times 1 is 2 times 1 is 2. And 40 divided by 2 is 20. So the total area is the area of the rectangle, which is 30, plus the area of the triangle, which is 20. So total area equals 50. Total area is the area of the rectangle plus the area of the triangle, which was 20. 30 plus 20 gives me 50. Okay, last figure, last example for today. All right, so what we have here is one big rectangle, A, B, C, D. And we have these shaded regions here and here that meet at that point in the middle, E. So what you want to find is the area of the shaded region. Well, you do that by calculating the area of the big rectangle, which is going to be length times width. And then we have to subtract the area of these two triangles. Okay, I read that problem wrong. You're trying to find the area of the unshaded region. So you take the area of your whole rectangle and then subtract out those two areas, and that'll give you what's left inside the rectangle. Okay, so we're given the distance between A and B is 6. That's the top part of the rectangle. Distance between B and C is equals 9. And we're given that point E is halfway between the distance AB and DC. So E is a midway point. Or E is a midpoint. Well, if you think of it this way, if from here to here is 9, right here to here is 9. Well, if E is halfway here, then it means it's half of 9. Well, 9 divided by 2 is just 4.5. So that line I just drew represents the height from this base up to point E, and that value, that height is 4.5. So to calculate the area of the big rectangle, that's length times width. Length, which is 6, times width, which is 9. And 6 times 9 is 54. And that's the area of the rectangle, 54. Now, to get the area of this triangle, we're going to use the formula 1/2 equals base times height. Since the distance from A to B is 6, the distance from D to C is 6. because this big figure is a rectangle, and in a rectangle, opposite sides are equal. So the area of one triangle, 1/2 times the base, which is 6, times the height, which is 4.5. Area of the triangle, 1/2 times 6 is just 3. Times 4.5. That can be written better. 3 times 4.5. Which equals 13.5. But that's just for one triangle. But we got 2 triangles. So if this one triangle has an area of 13.5, the second triangle has an area of 13.5. So the area for both triangles is 13.5 plus 13.5, which equals 27. Because remember, E was the midway point. So from here to here, that height is still 4.5. So when I calculated the area for this triangle, I would get another 13.5. So now to get the area of the unshaded region, area of unshaded, it's going to be the area of the big rectangle minus the area for both triangles, which is 54 minus 27. And 54 minus 27 equals 27. And that is how we calculated the area of the unshaded region. We calculated the area for the big rectangle, A, B, C, D, and we subtracted the area of this triangle, which was 13.5, and the area of that triangle, which was 13.5. And that left us with the area of the unshaded region. All right, y'all, take your time. If you need to go back and watch a little bit, please do. Rewind, take notes, keep practicing, as I will too. Take care. See you in the next video.